Okay, this video is hopefully going to teach you how to use and read a dial caliper. Dial calipers. Dial calipers are arguably the most common and versatile of all the precision measuring tools used by engineers and manufacturers. Now, like a micrometer, this reads in thousandths of an inch, but unlike a micrometer, instead of reading only 1 inch at a time, this dial caliper can make measurements from 0 all the way up to 6 inches in increments of thousandths of an inch. So it's a lot more versatile than a micrometer, although not quite as accurate. Okay, with the dial caliper, we can make 4 different types of measurements. That's another reason it's so much more versatile. Dial calipers are used to perform 4 common measurements on parts. 1. Outside diameter or object thickness, with these 2 faces right here. Inside diameter or space width, with these 2 faces right here. Step distance and hole depth, with this component right here. Okay, 4 different types of measurements. These are the faces between which outside length or diameter is measured. Used a lot like a micrometer. Whatever you're going to measure, you put it between these 2 faces. And here's an example of measuring the outside diameter of an object with a dial caliper. These are the faces between which inside diameter or space width, like slot width, is measured. And this is how I would measure the inside diameter of a hole or something like that, using these 2 faces. These are the faces between which stepped parallel surface distance can be measured. And here's an example of that. I can measure the step from here up to here using these 2 faces. And these are the faces between which the depth of a hole can be measured. I can also measure step distance here. And this is how I might use a dial caliper to measure the depth of a hole or a step or something like that. Now let's talk about the nomenclature or the different parts of dial calipers. A standard inch dial caliper will measure slightly more than 6 inches. Notice we've got a blade here that goes from 0, 1 inch, 2 inches, 3, 4, and on up to 6 inches. The blade scale shows each inch divided into 10 increments. Each increment equals 100 thousandths of an inch. So that's a lot like a micrometer. Each of these numbers indicates 100 thousandths of an inch. So here's 100, 200, 300, 400, 500 thousandths or half an inch, 600, 700, 800, 900 thousandths of an inch, or 1,000 thousandths of an inch, which is 1 inch. The blade is the immovable portion of the dial caliper. This is what reads from 0 all the way up just past 6 inches. The slider is what actually moves back and forth and changes the position of our measuring faces. Okay, this is called the slider. The slider moves along the blade and is used to adjust the distance between the measuring surfaces. The pointer rotates within the dial as the slider moves back and forth along the blade. Now notice, this dial is broken up into 100 individual marks, so each one of these marks is worth 1,000th of an inch. So as I move from 0 to 100 thousandths, this dial is going to make one complete revolution. Okay, and each time I move to a different numbered mark, I'm going to get another additional complete rotation of the dial. 0, 25 thousandths, 50 thousandths, 75 thousandths, 100 thousandths. This is your reference edge, so be careful. This is where you're going to take your reading on the blade and notice whether it's before or after a 100 thousandths numbered line. Okay? You don't count the numbered line until it's past this reference edge or on that reference edge. And this gear-toothed rack is used to change the linear motion of the slider into rotary motion at the pointer. So as I move this slider back and forth, there's a gear on here that actually moves that dial round and round one way or the other. Okay, reading the dial caliper. Okay, here we've got a complete inch. Each one of these numbered lines between the inches is worth 100 thousandths of an inch. And each numbered line is worth one complete revolution of the dial. 0, 50, 100 thousandths. On to the next number, I'm going to read 0, 50, 100 thousandths. The dial is divided 100 times, with each graduation equaling 1,000th of an inch. Each of these little marks is worth 1,000th of an inch. Every time the pointer completes one rotation, the reference edge on the slider will have moved the distance of one blade scale increment, or 100 thousandths of an inch. So one complete rotation of this equals the movement of this reference edge to a new number that indicates how many 100 thousandths we've moved. So here's 600 thousandths and 25 thousandths past the 6. So that would be 625 thousandths. And I move it a little bit farther, and I've got 650 thousandths. Move it again, reference edge is past the 6, so it's 675 thousandths. And finally, I'm lined up with the 7 on my reference edge, and my dial is reading 0, so that's 700 thousandths of an inch, or 0.700 thousandths. To determine the outside diameter of this section of pipe, the user must first identify how many inches are being shown on the blade scale. How many inches do we have here? We've got 1 inch shown on the blade scale. The reference edge is located between the 1 and the 2 inch marks, so the user makes a mental note, 1 inch. I'll record that on a piece of paper if I need to. The user then identifies how many 100,000th increment marks are shown to the right of the last inch mark. In this case, there are 4 past the 1 inch, so that's 400 thousandths past 1 inch. Like so, 1 inch, 1, 2, 3, 4, 400 thousandths. Next, the user looks at the pointer on the dial to see how many thousandths it's pointing to. In this case, it's pointing to 37, or 0.037, or 37 thousandths of an inch. 1.43567. And I'm going to add all those up. And I'm going to get 1 inch, 437 thousandths. 1 inch, 437 thousandths. Okay, let's see how wide this block is. We've got 1 inch showing here, so it's 1 inch. We've got 4 numbered lines. Each of those is worth 100 thousandths, so that's 1 inch and 400 thousandths, 1 inch here, 400 thousandths here. And how far past the 4 are we? 1 thousandths, 2 thousandths. Add them all together. Always keep your decimal points lined up. And we got 1 inch, 402 thousandths. Well, that's as complicated as it is to learn to read a dial caliper. Okay? Once you understand micrometers, you understand dial calipers a whole lot quicker, I hope. And this is a photograph of an actual dial caliper that we have in the shop. Notice this one not only reads in thousandths of an inch on this scale, but it also reads in millimeters on this scale. That's inches down here, centimeters up here, and millimeters on the scale. Okay. Hope you enjoyed the video. Thanks for watching.